So on this video, I'm going to demonstrate using the fact that similar triangles, the lengths of the sides are proportional to compute the lengths of sides of a triangle. So here we have the 30, 60, 90 degree triangle. That's the largest angle is pi over 2, the next largest one is pi over 3, and the smallest angle is pi over 6, right? And I've been given that the length of one leg of this right triangle is 5. That's the longest leg. The hypotenuse is A, and the other leg is B. And I'm supposed to find the lengths of A and B. And one problem students have is they'll immediately go to Pythagorean theorem because they're so used to using Pythagorean theorem. But for that, you'd have to know to find A, you'd have to know what B was. And to find B, you'd have to know what A was, because that uses the lengths of the sides. And it doesn't actually use any of the angles other than the 90-degree angle, because the Pythagorean theorem only works for a right triangle, that is one with 90-degree angle, or pi over 2. So this one I know I need to use similar triangles because there's two sides I don't know. And for the Pythagorean theorem is really not useful here, because I would have to know two of the sides, the lengths of two of the sides. So it says find A and B, so you have to know that you have to use similar triangles or you won't be able to do the problem. So make a note of that in your mind and probably on paper. If there's two unknown sides and it's one of these common triangles, then you're supposed to use similar triangles. So I write out my template, which is always the same for the 30, 60, 90. It's like this. Lengths of sides 1, the shortest one's 1, hypotenuse 2, the longest leg is square root of 3. Square root of 3 is opposite pi over 3, right? I've got the angles and the corresponding sides, the opposite sides colored for you. Anyway, so you just do proportions. A, the length of this side, over 2 equals, and then use the one you know, 5 over square root of 3. So this one over this one equals this one over this one. I could do it other ways too. I could do A over 5 equals 2 over square root of 3 if I wanted to. But I like doing the similar sides over each other. The hypotenuse over the hypotenuse in this case, A over A, and 5 over square root of 3. Just make sure you don't do the second one upside down, right? So I'm putting the numbers from this triangle on top, the numbers from this triangle on bottom. And the left side of the equation is the hypotenuse, and the right side was this. You could set it up different ways as long as you're consistent, right? Like consistent, you don't have the hypotenuse on top on the left, and then on the right, I'm sorry, you don't have, what would be inconsistent? So A over 2 equals square root of 3 over 5 would be inconsistent. That's just, for some reason you flip these last two around. So put these ones on top and these ones on bottom, or you could put these ones on top and these ones on bottom, but I just prefer to have the variable on top, the thing I don't know on top. And then you would do the same thing with B after you find this. So this you just cross multiply, you get 10 over square root of 3. And unless it tells you to rationalize the denominator, if you know what that is, hopefully you do. Unless it tells you to do that, just leave it. Or if there's a factor of 3 in the numerator, then you probably want to rationalize it because it'll reduce. So I get 10 over square root of 3. B, so B over 1 equals, and then the one you know, 5 over square root of 3. Actually, you could use this one now too, but I'm just going to use the one I knew to begin with. So B over 1 equals 5 over 3. See, it's the same setup. And that just gives you B as 5 over square root of 3. I meant the square root of 3, of course. b is 5 over square root of 3. Because the 1 doesn't mean anything there, right? It doesn't contribute anything. Okay, so that's... And of course, you would do the same thing if it was a pi over 4, pi over 4, pi over 2, except that your lengths of your sides here would be the isosceles right triangle, right? The lengths of sides would be 1, 1, and 2. So really, you just have, you know... If this one was unknown, well, it's already known, so you would just be asked to find this one. Or if you'd be given this one and asked to find this one. Right? But it always works the same way. You just do a proportion.